we all know the difficulties and the challenges of only having a static system. And with the beauty of organ-on-chip model, we really want to improve the whole model in a way that we really can get more insight into the whole human norovirus infection mechanisms. My name is Nicole Engert and I'm working as a postdoc in the research group INSPIRE at the University Hospital of Jena, headed by Alexander Mosik. And my research topic is the establishment of an adult stem cell-derived gut-on-chip model to elucidate human norovirus infections. So the research question we wanted to answer is how the whole human norovirus infection system can be improved by having a microfluidic flow within the whole system. Because at the moment, the gold standard for elucidating human norovirus infection is using transfer models and 96 well plates. So we all know the difficulties and the challenges of only having a static system. And with the beauty of organ-on-chip model, we really want to improve the whole model in a way that we really can get more insight into the whole human norovirus infection mechanisms. We actually chose using organ-on-chip models because we already have a lot of experience in working with organ-on-chip models in our research group. So for many years we are using that for different organ models, and we saw already that this microfluidic flow having in an organ-on-chip model really is improving the whole maturity of the epithelial cells. And therefore, in my project, which I'm conducting as a postdoc, we also want to have that added value of the increased maturity in the human norovirus infection model. Of course, I'm very happy to show you the details of my model for the human norovirus infection. So actually, we do have a gut epithelial cell layer in one chamber of the microfluidic chip. And when we started the project, we only had that. On the other side, we of course also can add a vascularized tissue and also tissue-resident immune cells, in this case macrophages. But when we started, we really only wanted to have a look on the gut epithelium itself, since it is known in literature that only those duodenal gut epithelial cells are able to get infected by the human norovirus. But the beauty of this model in general is that at the end of the project, we are able to also integrate immune cells, for example, also in the gut epithelium itself, or then at a later stage, when we have a vascularized tissue, we can introduce immune cells into that tissue, or even let immune cells circulate through this vascularized cavity, and then having a look on what is the impact of those immune cells on the whole infection system taking place in the cavity with the gut epithelium. The most interesting results of my study so far were when we started the project, we of course first did trials using the gold standard system, the transfer systems, which is used by other groups in the human norovirus research field. And when we then went one step further into the organ-on-chip model using the adult stem cell-derived intestinal epithelial cells, we were able to see an increase in the ribocopy numbers only going from the transfer system to the organ-on-chip system, where we also at the beginning had a static cultivation, meaning medium exchange once a day. And when we then increased the complexity one step further, having a dynamic flow for the cultivation of the intestinal epithelial cells within that chip system, we could see again an increase in the ribocopy numbers after the infection of the cells with the human norovirus. And that really nicely showed that the value of having a microfluidic condition within this chip system, really improving the whole infection process, making it very robust and also very reproducible. The organ-on-chip technology was definitely useful for my research project because it really was showing the added value of the whole organ-on-chip technology and really improving the whole infection process. So to use an organ-on-chip system is really something, it is, especially at the beginning when you never worked before with that, very good to get handling training. It is different compared to transfer systems because of the whole chip, the chip design itself, then how to connect also the chips with adapters to the tubes, to pumps. There are some small details which are very critical, that the whole system really stays stable, that there are no air bubbles introduced. So with regard to that, it is definitely necessary to get a proper training before really starting with your whole research field or with experiments, with the project, which really, I would say, takes some time, some weeks actually to really feel comfortable in doing that. But once you feel comfortable, it is very easy.